Welcome to this online tutorial on unit systems in Flexcom. My name is Angus Connolly and I'm the product manager for our Flexcom software. Let's start by covering some basic points. There are two unit systems available in Flexcom, metric and imperial. You'll recognize a metric project because it is input files with the extension KEYXM, where M stands for metric obviously, and imperial KEYXI, where I stands for imperial. Both of these systems have explicit units included in all the input and output data. So every input parameter is defined in base units, for example length in meters, but you can also define parameters in any other acceptable units, so length in millimeters, centimeters, kilometers, even feet and inches if you want to put that into a metric file. We'll cover that later. Output files also have meaningful units, so if you look at a plot of effective tension, it's in kilonewtons. Previous or earlier versions of Flexcom didn't have any unit systems, so you'll recognize legacy projects by looking at the file extensions. In this case they have input file called KEYX, so there's no units, so the input values don't have any associated units, neither do the output values, so the onus is on the user to ensure a consistent set of units throughout. You're free to continue using legacy input data which doesn't have any associated unit system, but obviously we don't recommend that. That goes without saying. So let's now look at the benefits of using unit systems in Flexcom. So I'm now going to create a brand new project in Flexcom with units. So I select File, New, Project. I give the project a name and a location on the hard drive. Now I'll need to add an input file. So File, New, File. And at this stage I can choose between metric, imperial, or legacy or unspecified. I'm going to choose metric because that's the system I'm most familiar with. Once I've got the file open in front of me, I can start to add in some information. So let me just add in a very quick line. I'll just call it line equals simple. That's just the name of it. It starts at the origin. It ends at point B, which let's say is 10 meters in the vertical and horizontal direction. So it's in the XY plane, and I'll use a 1 meter element length. So let's just look at that model in the model view. There we go. It's got 14-15 elements in it. So the benefits of using unit systems in here, I'm already using a metric input file, so all of these inputs actually have units associated with them. So if we look at the endpoint, the endpoint is 10 meters in the X, 10 meters in the Y, and 0 meters in Z, and the suggested element length is 1 meter. But down in the keyword file, it doesn't. The units aren't immediately obvious unless I hover over each item, and then I can see the units. But I could also make this more explicit if I just typed in these angle brackets, which actually explicitly tells the program that that's 10 meters in the X and Y directions. And I can also say that the mesh density is indeed 1 meter. So that's exactly equivalent to what I had specified a moment ago. It's just that I'm being more explicit about the units that I'm using. So this is much more clear for anybody who's inspecting the keyword file later on. So the units are expected in meters, but if I wanted to use something else other than meters, I can also do that. So 10 meters, I could put that in as, let's say, if I was to increase that to, let's say, 100 meters and 100 meters, I'd have a longer model, so it's 100 meters in both directions. But I could also replace this one 0.1 of a kilometer, which is the exact same thing as well. I could also replace that by some input which is similar to 100 meters, so let's say about 300 feet. So again, it's equivalent. So you can see the Flexcom is clever enough to accept any different combinations of units that you specify. So if you're worried about making a mistake, you don't need to be worried, because if I type in meters, it accepts it. If I type in meters with the American spelling, it accepts it. If I type in just M for meters, it's also acceptable. And if you make a mistake, like you type in something silly, then there's obviously a warning to tell you that it couldn't be interpreted as a type of dimension. So you can see the benefits already of having the units there, just for clarity, and also for the combination or the intrinsic conversion of units in Flexcom itself. Now if I wanted to, I could also introduce some very basic parameters in the preprocessor section. So I could maybe have a parameter for length and assign that as 100 meters. And then down here I can actually reference that parameter rather than typing in the units or the inputs explicitly. I can say that that's equal to length in a particular direction, Lx or Ly are the same here. And I could parameterize the mesh as well if I wanted. The benefit of doing this is if I change one unit up here, then I've obviously changed 2 units down below. I could do the same for mesh as well if I wanted to. So let's say I have a mesh length here. That's highlighted now because I don't have the parameter mesh defined, but I'll quickly rectify that. And I'll say that my mesh is, just say we're back to a 10 meter. So you can see the benefit of parameterization. If you just want to check the length of the model, just to check that everything is okay, the total length of 15 meters. That's because I've got it in 2 directions, so I can just put it back into 1 dimension there. And if I was to measure this, total length there is about 10 meters, which is exactly what I want. At this point, I think I should maybe just switch to a more detailed model. So I'll just open up another example. This is a standard, one of the standard examples from the Flexcom example set. It's an S-shaped riser configuration. So this would be like a legacy model that somebody might have already built. So again, once this is in metric units, I've got the KEYXM extension. I'm good to go. All the units are already inbuilt. So you can see that water depth is in meters. I'll just maybe bring that up there as well in the table editor. So you can see that I've got all the units inbuilt. If I wanted to, I could again be more explicit and I could say that's 300 meters. Or the beauty of doing that is that it's very clear to the user what units I'm using. I could also say that it's roughly about, let's say, 1000 feet, which would be similar water depth, slightly higher. If you hover over any value, it tells you exactly what the converted value is. So that's 1000 feet and it's been converted internally to 304.8 meters. So again, there's clarity about what's happening inside the file. The reason I wanted to show you this slightly more complex model is that when you go into post-processing, if I look at a plot of effective tension, I'll just close the model view for ease of viewing, and now switch on to a plot of effective tension for that example. So the effective tension is measured in newtons, which is not particularly helpful because we'd really want to measure that in kilonewtons. So I could instead, when I'm generating the outputs, I can say that I'd rather have that in kilonewtons. I'll just skip down to the keyword editor here. But the beauty of this is I can actually maybe also request the same plot. Let's go for newtons, kilonewtons, and also let's try kips, which is also a unit of force, but this time in the imperial system. So let me just run the post-processing on that analysis. So if I just double click to open the file, I've got my original plot for effective tension in newtons. If I scroll on to the next plot, I now have the exact same plot, but now this time the units are in kilonewtons, which is much more useful, much more meaningful units for effective tension. And finally, if I scroll on to the last plot, I've actually got the same data, but now it's in kips, so it's in the imperial unit system. So even though we've chosen metric as our standard system throughout the project, we can actually input some units in imperial if we want to, and we can actually transfer the outputs to imperial as well if we need to. So this can be very handy for transferring information, let's say, between Europe and America with different engineers dealing in different unit systems. So that's really, really useful. Finally, I'd just like to quickly switch back to the very, very simple one, and just to mention quickly that we can, if you want to check what any conversion factor is in Flexcom, you can just create an arbitrary one here. So I'm going to go meter to feet as a parameter, and then I'm going to go equals, I'm going to use an equation here called conversion. I'm going to convert the value of 1 from meters over to feet, and just close the bracket there to finish off the equation. And you can see that the 1 meter is equal to 3.28 feet. So just to say that, as well as the default conversions, which, for example, in lengths, if I'm using a metric file, all of the values that I type in are transformed back to meters. So if I type in millimeters or centimeters or feet or kilometers, they all get transferred back to meter. But occasionally I might want to use something different and find out what different factors are. So I could let's say I could check what how many centimeters are in in a feet, and I can just copy that across there. They're obviously quite straightforward, but it just shows you the power of the conversion systems in Flexcom. If there are any unit conversions that you would like and that they're not currently in Flexcom, then just please let us know, and we can add those very quickly for you. So that concludes the tutorial session on unit systems in Flexcom. I hope you've enjoyed it and hope that you've learned quite a bit from it.